Asthma New Zealand's mission is a 50% reduction in asthma hospitalisation by 2029. The health of our homes is getting in the way of us achieving that mission. We've received a call from a family that are living in a home that's making them incredibly sick. We're going to go and find out what's going on, and we're going to take you on that journey. A few weeks ago, we got a call at Asthma New Zealand from Lindy. She was beside herself, a mother of 2 young kids. All the family are incredibly unhealthy. This is not unusual. We get a lot of these phone calls, but for some reason, this family really tugged at our heartstrings. And so today we're out in Papakura to have a look at this house. Asthma New Zealand don't know much about building sites, so we've teamed up with Oculus architectural engineers to get their expertise and help us with this project. Let's get this house healthy for you. Mould is a huge issue in New Zealand. I don't think there'd be one house that doesn't battle with mould. As long as there's moisture, there's going to be mould. For anybody with respiratory issues, mould is a really serious trigger. It gets into the airways, which then causes them to contract, and that is what brings on asthma attacks. You just cleaned this, haven't you, last week?
Yeah, so it's like stained and eaten into the wallpaper. So I mean, the only thing is stripping the wallpaper back and, you know, trying to resurface the jib without having to replace all of the jib.
You've had the home for 10 years?
Yeah.
And you've seen just the problem, no matter how hard you work.
Yeah, every weekend it's kind of just, you're just cleaning all the time to try and make it healthier because you've got no time during the week. On the weekend it's just trying to fix the problems all the time, so you don't actually get any family time because you're just
constantly trying to keep your house
dealing with the mould so that you don't have sick kids on top of everything else.
New Zealand's had the second highest rate of mortality for 5 to 35-year-olds for 20 years now because of asthma. We can keep throwing drugs at this problem, but it's like trying to fill a bathtub up without a plug-in. I can't believe that the sector thinks it's acceptable to publish 53% of houses unknown to them as to not meet minimum healthy home standards. It seems astounding. Now, when you walk into a house like this, what are you looking for?
When I walk into a house like this, it's not thinking this is worse than normal. I'm thinking this is probably going to be a typical New Zealand home.
How has New Zealand got to the position whereby, 53% of our houses are unfit for human habitation?
I think it's a long story. New Zealand has been isolated from the rest of the world for so long. It does take a long time for technologies to arrive here that have been in other parts of the world for a while. It's how you build to actually prevent those things from coming into the house and keeping the inside of the house healthy. That's what we need to focus on.
It seems to me that this is such a big problem. Where do we start?
The first step is to have a look at your house. How is it performing? Do you have mould issues? Is it too cold? And then start looking about what simple measures you can do about it.
Understanding the simple measures that Oculus suggests is going to be really important for us. Asthma New Zealand want to help you understand what these simple measures are and how you can apply them to your internal environment.
Adam has ongoing allergy issues, but he's always so snotty and coughing that with COVID we've had to now do the COVID test to prove he hasn't got it so we can go into daycare. But it's something he's had since he was a baby. Winter times are normally spent with the Vicks vapor going all the time to the point that the house is so steamed up that it's actually started to peel the wallpaper. That added to the mould growing on top of everything because it was so wet. And my 1-year-old, from when he was 6 weeks old, we ended up in hospital all sorts because his nose was just shut and he couldn't feed and breathe at the same time. So he's considered a high risk with his sinuses and everything as well. I don't feel like we ever get a break. It's just battling one sick kid after another and, us getting on top of it. You're too embarrassed for people to come in because it smells musty and mouldy, even though you're cleaning constantly. I get home every night, I'm vacuuming or sweeping and wiping things down. It's just constant, but you still feel like it's not good enough and you can't ever get a break or get on top of it, ever.
So today we're going to be testing where is all the leakage and looking at some of the ways that we can make improvements. Everything works as a system. You can't just plug a gap and not deal with the ventilation issues, because you plug a gap and now no air's coming in or going out. So Denise, tell me, what is this machine actually doing?
So this is the blower door machine.
Yep.
So we're placing it airtight into an external door or window if we can. And the fan is blowing air in or out of the building. And with all the tubes, we're just measuring the pressure difference and how much air is going in and out of the building. And from there we can calculate how air permeable the building envelope is.
You call it the envelope. We would just typically call it the walls and the roof and the doors and windows.
Yes.
So it's how much air escapes out through that is what we're trying to measure here.
Exactly.
And why do we want to know that?
Well, because with air going in and out of your walls, roofs and windows, you have energy losses, and you can also get drafts that are feeling uncomfortable for people living in the houses. Plus they contribute to high power bills, particularly in winter.
Here, New Zealanders talk about continually the exorbitant cost of power. And so if we've got all this leakage that's occurring in our walls and windows and doors, what we're effectively doing is just wasting power.
Exactly right.
We're pumping some theatrical smoke into here, so that's why you're not coughing,
Theatrical smoke.
Yeah,
I like
yeah.
this theatrical smoke. And so, because that's why we were standing outside and we could see the smoke coming out of the windows.
Yeah, so we're pumping heaps in here, and you can see it coming out through the gaps and cracks in the building.
And so that's why we're wanting to do this blower door test, basically to identify where's all the leakage in this house. You know, how is the cold air getting in and how's the warm air getting out? Big reveal.
Big reveal.
What have we discovered?
We've discovered that the building has got a permeability of 7.77 cubic meters per hour per square
What
meter.
does permeability mean?
Technically, the equivalent leakage area that we're talking about of the entire surface of the building is 0.0763 square meters.
What? So that's about that.
All the holes
that's
together.
Not that much
All
bigger
the
than
holes together. That's the
Yeah.
size. 7.77 is about that size. About that size.
that 7.77 figure. For a new house in Australia, that has to be less than 10. The UK, it's 7.5. So what we're saying is that that's equivalent to around about so a good building in Australia
Right.
and a new building in the UK.
In the UK. Today we've been able to identify that in terms of the total air leakage in your home, it's, if we were to put all of the leakage areas together, it'd be a hole about that size. Yeah. However, I'm reassured that that actually isn't as bad as a lot of homes in New Zealand. And so it's not so much about the air leakage here, it's about ventilation.
One thing which is the same for any house everywhere we are is that people live in them and people breathe and they have showers and they clean and they wash, all that sort of stuff.
What we're supposed to do in a house, yeah?
Exactly,
Live in it.
exactly, yeah.
Yeah,
And when
yeah.
you do that, you're breathing out moisture into the air. And if you've got cold surfaces, you know, your windows are the classic one, you'll get condensation forming on those windows. And so that's a challenge, right? Because if it's foul weather, if it's winter, you want to feel like you keep your windows closed to keep any warmth that you have in the house inside. Yeah. And yet, you need to be letting the moisture out.
In the middle of winter, that doesn't feel great.
That's right. That's right, because it's cold outside.
Yeah.
And you want to keep it closed. And of course, when you do open the window, it's got to be windy. Unless it's windy, you're not getting any air flow through the house, generally.
Just opening up some windows and just allowing the cold air to gradually creep in, but it actually, unless there's wind, it's not going to
it's
do.
not going to push through so quickly. You know, it's not going to. And so we're trying to get rid of moisture. There's a few different ways of doing that, but an extract fan in the bathroom is pretty important. Of course, a whole house ventilation system, it's going to do a whole lot better.
Asthma New Zealand do not feel that we have a choice not to get involved now with healthy homes. With 87% of our patients living in homes unfit for human habitation, it's really critical that we start addressing the health issues that our houses are causing. If there was one thing, let's say Jacinda with her magic wand was standing here now and she was going to grant you one wish in terms of fixing this housing crisis in New Zealand, what would it be?
Free heat.
Free heat.
You would allow the windows to be open for a bit longer to remove some of the moisture.
Yeah.
You'd have a fan running for longer to remove moisture out of your bathroom.
With our young kids, we have to be doing everything we can to keep their respiratory system healthy.
Yeah.
Because once that system's been compromised, it becomes chronic.
It makes you feel like a failure as a parent because you can't provide your kids with that healthy. We've bought our own home, and that's one of the issues as well. We own our home now, so it's not like we can call somebody to fix it when something's wrong. We've got to try and scrape together that money to fix anything that needs to be done, and you just can't get on top of it sometimes. The amount we spend on treatments trying to improve their health is taken away from us saving that money to do the big improvements on the house. So little tips that can make a difference are huge,
Look, Lindy, thank you so much for allowing us into your home today.
Well, thank you for coming. Any help we can get, we will take, really.
Talking to Lindy absolutely breaks my heart. I cannot believe that she has just said that the Kiwi dream is not a Kiwi dream at all. I cannot believe that she has just said that as a mum, she feels like she's failing her kids. The problem that we're facing with our housing in New Zealand is not one that one sector on its own is going to fix. Blame is an absolutely useless solution. It will not change the position that we're in now. So we turned up here this morning at 10 o'clock, me with no idea as to what I was going to expect. All I knew is that what we were doing was coming to a home whereby we've got a family that are incredibly unhealthy on the basis of what this home is doing to them. Having spoken to the team from Oculus and having seen the blower door test today, they weren't surprised by what they discovered. For us, what we now need to do is going away and thinking about, okay, what are some of the small improvements that could just lift the health of the house just a little more? Lindy and Joe's house has left me with more questions than answers. There's so much that does not make sense for me. Oh, I cannot believe in this day and age that we cannot be living in homes that keep us healthy. So today I'm at Biz Dojo, and really it's quite fitting. It's one of the innovation and entrepreneurship hubs in Auckland. So we're going to meet Brandon, the CEO and founder of Tether. Tether have made these intelligent environmental devices that will provide us with raw and real data to understand the health of Lindy and Joe's home. So Brandon, we were contacted by this beautiful family out in Popokura. They've got a Kiwi dream that's turned into a nightmare. The house is so unhealthy, it's making them all sick. And we want to get our heads around what's going on in this house. Are you in?
I'm 100% in. This is a natural occurrence. We see this a lot. We know exactly what to do. We can definitely help.
Awesome. So the last time we were here, Oculus helped us understand how much air was going out of the house and coming into the house. Now we need to understand what's going on in the internal environment. And so we're coming today to install the Tether Sensors. That's going to help us read what's going on in this house every day. Last time we were here, the windows were crying. So why is there no condensation on the windows today?
So what forms condensation?
Yeah.
Moisture hitting a cold surface. So we've got the moisture there, that's coming out of the fish tank. So what are we missing? If the moisture's there, we've not got any condensation. We're missing the cold surface.
You're hearing a lot about us talking about removing moisture from inside the house. What we're talking about is removing condensation. So let me show you what condensation is. Condensation is basically when hot moisture hits a cold surface, you can see what's happening inside this jug here. It's all steaming up and it's starting to form moisture pockets. We see it in the shower. Our glasses fog up if we breathe too heavily. Or in the microwave we've cooked something. That is why it's so important that we ventilate our houses to get that excess moisture out. Because if we don't, that condensation needs to go somewhere. What were the problems that you identified?
You go through essentially what are the issues at the house.
Yeah.
Leakage or air tightness is one potential issue. How that building is heated and ventilated, how much insulation it's got and where it is, what the glazing performance is another issue. Those are the things that you look at holistically. So we've got floor insulation, we've got ceiling insulation, we've got a heat pump. The biggest single issue, and this is it's wrong to try and focus on single issues because you have to consider the whole thing as a mechanism, as a system or a machine, was the lack of ventilation. And it's certainly not worst performing house that I've ever seen.
So it's not the worst performing house that you've ever seen. The occupants in this house are not well. This house is not keeping them well.
No, that's again coming back to the idea of just because one thing is performing reasonably well doesn't mean the whole thing is performing reasonably well.
Brandon, the last time we were here I brought so-called geniuses in with me, okay, and they set the fire alarm off. It looked a lot like this, all right, so I'm a little bit worried. You know, what is this going to do?
Well, this is our Enviro-Q Sensor. So this is basically our environmental quality monitoring device that will tell you how healthy a space is or a room is. What it monitors is temperature, relative humidity, dew point temperature, carbon dioxide, and light and atmospheric pressure.
All from that one little
from this little
device.
thing. What we talk about at Tether is your home being its own digital persona, its own personality. And what we do with our sensors is we give your home the ability to talk. And so you can listen to what your home is saying and then act accordingly.
It was so important for Asthma New Zealand to feel confident that these sensors would not breach anybody's privacy. These sensors only collect the data relative to the internal air quality of this house, protecting the private data of our patients.
At the end of the day, the house is supposed to be built to look after you.
Yeah.
You move into a home because it's supposed to be warm, dry, safe and healthy.
That is a novel concept in New Zealand. We're beholden to so-called experts, but you know, sadly it feels like the experts have let us down in many respects from a building perspective. You know, given the number of houses that are making us so sick, if we don't start to educate ourselves, I think that we really are going to be battling against it in terms of improving our health. And I know that the living environment that we're in has such a big impact on respiratory health. I was never educated to think that way. We don't need to make huge, whopping, great big changes here. The way we live in our houses can make a big difference to the internal comfort of our home. But we need to know what those changes are, and we've never been educated around this. And what I'm curious to know is, where are you going to install it and why are you going to install it there?
With our devices, we want them to be at living height, right? So living height means if you're sitting down on a couch or you're standing up, you want it to be in that section. But if I put the sensor right at the top, if this was a real tall ceiling, you would probably find a few degrees centigrade temperature differentiation at the top. And you'd see it much colder down at the bottom, which is why you normally get mold spots in the bottom of corners, because that's where the cold air sinks and it starts to condense the water and the mold starts to grow in the corners.
So by installing the sensors in the different rooms, it's going to give us the ability to look and measure and understand what's happening as Lindy and Joe move through their house and live in the respective rooms.
I wonder if those walls are too wet. Yeah, you can feel like the stickiness has been removed completely because of the wetness of the wall.
I have found one sensor. So what you're telling me in all seriousness is that
This
wall
is damp.
is actually really damp.
You can feel it, yeah.
Well, you were just saying, looking at your device, that this room in here is at
80% relative humidity right now.
80?
And that wall is damp. I mean, 3M strips do not like, and this is not even sticky anymore.
And that's the impact of moisture.
Yeah.
Imagine, you know, they're sleeping in this room.
There are 2 openable windows there. Why is that not managing humidity? Why is that not an effective form of ventilation?
Yeah. We've seen the authorities publish, you know, open your windows for 15 minutes a day. They're doing that.
And it's not enough. The windows are wholly reliant on the weather for their performance. So on a day like today, when it's damp outside, you've got high humidity levels outside, you're just bringing those humidity levels into your home. But even on days where it is performing, it relies on you as the occupier opening the windows at the right time.
Yeah.
And it's the right time is about 8% of the year. Unless you can actually actively manage ventilation, you've got very little chance of it being right.
Why are you putting a sensor out here?
Well, we want to compare the outdoor environmental quality with the indoor environmental quality.
Right.
The house is meant to protect you from what's outside. It's not meant to rain inside. It's not meant to get freezing cold inside. So what you want to see is how the house is responding to outdoor environmental quality. So you'll see the relative humidity, which means the humidity that you're fighting against to control inside. So right now, based on that reading, we have a 75% relative humidity outside.
When you use the word relative humidity, is that the same as humidity?
Relative humidity is the water moisture or the amount of water droplets in the air in relation to the temperature.
Oh my goodness. Bless those boys. As hard as they tried, I still don't understand what relative humidity is. So let's understand this together. We know what humidity feels like. When we've got hot, humid days, we can feel that stickiness on the skin. That's the moisture that's in the atmosphere. Relative humidity adds in temperature. So an environment that's at 18 degrees can hold more moisture than an environment that's at 14 degrees. And this is why relative humidity is so important to us as occupants in a house. So if we've got our house heated to 18 degrees and our house is sitting at 87% relative humidity, which unfortunately a lot of Kiwi houses are, let me show you what ends up happening. You can see we're gonna get a little bit of moisture into the environment. A room that's at 14 degrees, let's have a look. We know what's going to happen here, don't we? You already see all of the moisture that's going to fall out of that room has got to go somewhere. And it's going to go into the curtains, it's going to go into the carpet, it's going to go into our bedding, it's going to go into the walls, and mould loves damp conditions. The other thing is that our respiratory tract does not like that moisture in the environment. And that's why relative humidity, aiming to get it between 40 and 60 is so critical.
The focus is always on temperature, because humans are very good at sensing temperature. You can tell if it's too cold or too hot. We're very bad at sensing relative humidity or humidity.
Yeah.
And that's why those devices are really, really helpful, because they can tell you when it's out of optimum range and what to do about it. That's the crucial thing, what to do about it in real time.
It's really quite remarkable something this small could provide so much value, helping us understand our environment first, because until we can understand it, there's nothing we can do in order to fix it. I'm super excited. We've had the sensors in the house now for a week, and Brandon's going to show me some of the data that they're getting and they're seeing. Brandon.
Catherine.
Let's have a look at what you've got.
We've been monitoring the house for about a week now,
Yeah.
just under. As you can see, things aren't great. We're sitting at 32.86% on our healthiness scale,
Wow,
which is
my
basically
goodness.
all of the metrics that we measure. And then as an average, how is that house looking.
But Brandon, what doesn't make sense to me is this house has got underfloor insulation, it's got ceiling insulation, it's got a heat pump in it.
It's fully compliant. It's fully compliant with the Healthy Home Standards.
And yet
it's fully compliant. And it's still really low. And if you look here, here's the interesting thing. Temperature, as you can see it, is actually not doing too badly. This green bar over here is the healthiness zone. It's where you want to be, between 20 and 24 degrees.
Yeah.
But look what happens when you click on relative humidity.
Oh my goodness
Look how damp this house is. There's only a very small percentage of time that the house is within the healthiness zone.
And there's times where it's up at 100%.
It's almost 100. It's pretty much raining in the room, right? You've got 99% relative humidity sitting at very small intervals of time within that main bedroom. It really is not great. And this is where your health conditions come from. And then if you start looking at CO2, which is your ventilation issues, that same main bedroom where you have that 99% relative humidity, look at how high these carbon dioxide levels get at night time, right? 2:30 a.m. at night, no ventilation, not opening doors, not opening windows, everything's shut. So not looking too good at the moment, Catherine, unfortunately.
No. I don't know about you, but I want to live in a 100% healthy home. Lindy and Joe's house is 32.86 healthy. We've got to do something. We've got to get that house so that it is a lot healthier for those young kids to grow up in. Imagine their future if they live in a house that's that unhealthy. We're back in Papakura for the day of the installation of the improvements. I am so excited that finally we can help Joe and Lindy have their home a little healthier. So let's go and say hello to Joe and the kids. Hi, how are we? Oculus have been monitoring the internal data from their first visit, so they now have a really good idea as to the improvements that can be made given the budget that we've had allocated. So as Asthma New Zealand progress on this journey, the one thing that's becoming clear is how little we actually know about building science, how little we actually understand about what it takes to live in our house healthy. So as we start to find all of this out, it's our job to make sure that every Kiwi knows what they can do to keep their home healthy and keep themselves healthy. In terms of the bathroom, what stood out for you?
From a temperature perspective, we're actually not too bad. This green bar over here is the healthiness band when you look at temperature. So the temperature's actually been quite good.
Yep.
But as soon as we pop through to the relative humidity graph, you can then start to see how we're not once within the healthiness band respective.
Absolutely.
Even the outside sensor has healthy relative humidity for some of the time over the last 24 hours. If we jump into the last 7 days, outside relative humidity is red, the bathroom is purple. We're just constantly sitting above the healthiness zone. You have these spikes of up to 100% relative humidity, which means there's so much steam built up in this, and it just stays there.
From the data that Brandon's taken me through today, it makes sense to the health issues that Lindy and Joe and the kids are experiencing. Let's have a look at the data from the kitchen, because as you can see, I'm boiling a pot here, and that steam is going up and it's got no place to go.
This house seems to be managing temperature quite well, but when you start to look at the relative humidity, which again is a big problem with this house, you can start to see how the graph just shows no time is it ever within the healthiness band.
Yeah.
Oh, well, there's some. Maybe one day for a few hours.
That's when they're probably not cooking.
When they're probably not cooking, but you can see these spikes that happen when the humidity starts to kick up. So on average, you're sitting at a 74% relative humidity within the kitchen. That's not good.
No.
It needs to be between 40 and 60. That's the healthiness zones.
Absolutely.
So an average of 74, not that great.
No. This is one of the main rooms that Lindy is in with the kids. What have we seen from this room?
From a temperature perspective, we're actually not doing too badly in this room. And it's probably because they've got heaters and stuff going on, which is fine. But as soon as you start to look at the relative humidity, over here you've got relative humidity sitting above 75% and going just above to 80 and sometimes outside the healthiness zone. So up to 85% peak and an average of 74% relative humidity. So again, At no stage over the last 7 days was this bedroom within the healthiness zone for
No.
relative humidity. Now, if you look at the CO2 levels, have a look at that. And when you've just got these massive
Wow.
spikes that happen overnight, up
Yeah.
to 2,000, 2,500 parts per million that go up and down. And as soon as you start to get out the healthiness zone, which happens pretty much every single night, what that is an indicator of bad ventilation.
Yeah.
So, it's just a systemic problem over
Yes.
here. Is
Yeah.
high percentage of relative humidity, insufficient ventilation,
Yep.
but you may not actually notice it all the time because the temperature seems to actually be quite good.
But in terms of relative humidity's going through the roof, all the moisture, and in terms of CO2, just spiking because there's no way of getting that change of air.
Yeah, there's just no air changes in this room.
How we live in our houses in New Zealand isn't helping the health of our environment. Kiwis are prolific for turning a heater on in a room that we're in, and then as soon as we leave it, we turn it off. This intermittent heating is causing a number of issues. James, right now we're cutting a hole in the side of their house. Why are we cutting a hole in the house? Why don't we just have a range hood that recirculates?
There's a phrase that says having a recirculating hood is about as much use as a recirculating toilet. You're not actually removing the issue, you're just recirculating it. Cooking can create some fairly noxious gases,
Yeah.
particularly if you use gas to cook with.
Yeah.
And so you really do need to extract those gases and the moisture to outside rather than just recirculate.
Just recirculate it. Yeah, that makes sense, absolutely. So now I understand why we're cutting a hole in the side of this house as opposed to just putting something that can, suck up the moisture.
Yeah.
After John's cleaned the windows, we've seen him lay a run of double-sided tape around the frame. What is he doing now?
So the process is we've obviously cleaned all the surfaces, the windows, the stuff that we won't be able to get access to. Then what we've done is we've put some double-sided sticky tape around the frame so the film can stick to the frame, not the window. So we've created that air gap, and now what John's doing is sticking this plastic sheet, which is cut to suit, onto that double-sided sticky plate tape.
So we shouldn't expect to see condensation form on these windows now?
No, we shouldn't. So we're creating a warm surface because we're insulating the window.
Yep.
And so what that's also doing is that's improving the thermal performance of the window by 80%. That's huge for $25.
I'm here to help. How can I help you, John? Where do I start?
I've finished. Sorry, you're too late.
I've finished?
Yeah, that's here. The film's on here.
Oh my gosh, that's amazing. I did not even see that there. What surprises me about this is your ability to still open the windows. I didn't think that we'd be able to do that.
Well, that's the ventilation part
Yeah.
of this room.
This hasn't taken long at all. It took you more to clean the windows than it did to apply this film. It's quite easy, isn't it?
It's not hard.
James, we've got the extraction fan in the kitchen. What was the price of this extraction fan?
That was $120. It was about an hour to install,
Right.
and it costs, if you were to run that constantly, it will cost you about 10 cents a day to run.
That's pretty amazing, really, isn't it?
That will take all the humidity out, and it will take all the contaminants from cooking, which are nitrous oxide, which is not particularly good for you.
No.
And so it's not that noisy. You can manage the amount of air extracted by switching this fan on. You know exactly how much air is being extracted.
Well, it's going to be really interesting to see now the data that comes out of this room with that extraction fan in it. And in the bathroom, we've got the extractor fan. James, what did that extractor fan cost?
That cost $240. It basically has two speeds. It's got a trickle ventilation, and then it's got a humidity sensor. So when it goes above a certain relative humidity, it boosts
It
itself.
kicks in itself.
Yeah,
Right. And how long did it take to install?
about an hour.
Okay. And the running cost?
So it's about 5 cents a day.
5 cents a day to keep this running automatically. It kicks in when it knows it needs to do its job.
Yep, so when you're having a shower, it will boost so that it will get rid of all of the excess humidity. But it also always is, if it's always on, you get a constant trickle of air movement through the house. All of the air extracted out of here will have to be made up by air coming through the gaps in the fabric or through open windows or any air coming in. For the amount of dollars invested, that's the crux of what we're doing here.
So this room is one of the problem areas that we identified in the house.
Yes.
And one of the recommendations that you've made is putting a heater in here and having it on a continuous temperature, running 24/7.
Yes. This device here is sensing the temperature in the room, and when the temperature in the room goes below a certain level, which you can set, as soon as it goes below that temperature, it switches the heater on to warm the room up so it's above that temperature.
That's going to be a really big struggle for Kiwis because we don't run our heating systems continuously. No. Why are you suggesting this?
So this wall here, if you recall when we came around the first time, Brendan tried to put the sensor up on that wall and it kept falling off. And the reason for that is because that wall's cold and the moist air is hitting that cold wall and it's condensing, and so you get natural liquid water on that wall, which is perfect conditions for mold growth. Our practice of intermittent heating is creating the mold cycle. So what we want to do is remove that cycle and have a continuous heating.
That's going to put our power bill through the roof, surely.
Depends. So what we're saying is at the moment when we switch our heating on, when we come back from work in the evening, we've got a big spike in energy because it's got to get from 10 degrees up to a comfortable temperature. So that's a big heat demand. It's a big spike.
Okay.
And that spike uses more energy than just having a low, consistent heat all the way throughout the day. So what we're saying, we're not going to have this at room temperature all the time.
No.
We'll just perhaps drop it down to 16 degrees when we're not here, and then it's not as big a ramp up when we actually do get back, so that you don't get condensation.
What a day. We're at the back end of it now. You know, when we turned up this morning, it was so much excitement knowing that we were finally getting to the point in time where we were starting to improve the quality of this house for its occupants. We've done everything that we came here to achieve. There's been so many people that have helped out today. And I just cannot wait to see the data over the next couple of weeks as to how this internal environment is going to improve. But more importantly, I can't wait to tap back in with Lindy and Joe to find out how they and the boys are. So several months have gone by since we first came out to Papakura, and today for me personally and then for Asthma New Zealand to come back out and see Lindy and Joe and the boys to see how is their health after the improvements that we made. I want to know, are the kids healthier? Have they gone to the doctors less? That's what's really important for us. And so to be able to see them today is going to be really important to understand what does it take to create a healthy home. Lindy, how are you all?
Doing really well.
Yeah.
It's been really good. Very few sick days.
And what have you noticed with the kids, in terms of their sinus infections and things like that?
So much better, so much healthier, lots more energy.
You guys got to go away for a holiday?
A very small little weekend away, which was great. There were no hospital trips on this one.
Oh, that is brilliant.
That's a first. There was no medication needed, no sick kids.
Oh, that is such great news. That is awesome to hear. Now, when we first came in, did you have any idea as to what it was going to require of you to keep the house healthy?
No, I thought that we were doing things pretty well. And when you came in, I thought it was going to be major things we were going to have to change. But cracking a window and having a fan on is really all that we've had to do. So it's been the simplest little things that we thought were so minor, we didn't realise would make such a big difference to the house.
I think it's interesting, isn't it? Because as occupants, there's little things that we can do to improve the internal health of our homes, and it's really just knowing what they are.
Yeah.
We took Lindy and Joe's house from 32 to 58% healthy with less than $1,000. Lindy and Joe were able to take their knowledge and apply that themselves. Asthma New Zealand are going to help you do the same with your house. We're going on a journey, Aotearoa. We need to have everybody in this country living in homes that keep us healthy.